Okay, the slide is visible.
Yes, sir.
So last time we started this, we are discussing the go back in AR cube error control techniques. It is based on sliding window flow controls. Earlier we have seen the stop and wait flow control, stop and wait AR cube, automatic repeat request. This error control techniques. One of another mechanisms. There are three mechanisms I told you for error controls. One is stop and wait AR cube. Another is go back in AR cube, and third one selective reject AR cube. Stop and wait flow controls, you have seen it. It is just based on the stop and wait flow control that we have seen earlier. But it's very slow process. It is inefficient. You have seen it. I mean, all the cases it is inefficient. I mean, it's a slow process, but it's very simple to implement. The most important technique is this go back in AR cube. Here also some drawback is there, that will see it. Let us first understand what is this technique, how it overcomes these damaged frames and also damaged acknowledgement. And I told you last time, if suppose the A is sending sending frames say 1, 2, 3, etc. Say I-1 frames transmitted and successfully received by B, right? Next A transmits say ith frames. Now if that frame is damaged, then what will happen? I told you the B, if that frame is it is damaged, but since A this time it is based on sliding window flow controls, so even A is not getting the acknowledgement, it will continue to transmit. So next next frame will be transmitted say I+1, right? I+1, but ith frame is damaged, but A doesn't know that ith frame has been damaged. Now B, after receiving these I+1 frames, B recognizes that it is out of sequence. Earlier it was I+1, next it is I+1, so one frame is missing. So B will send. B can take several actions, but this I say within some certain time intervals. If B discards these frames and you see send the negative measurement, I told you the REJI negative acknowledgement. Then after receiving this acknowledgement, the A will retransmit these frames I as well as the subsequent frames that already it has transmitted. So those things are there. This is one action. Another action I told you, say A does not send additional frames, B is also not responding. Then what will happen is after a certain time, when the time expires, then A will send RRP, this one command, RRP with P bit equal to 1. And this is actually B will treat this command as this command. This message will take as a command and it will be responded. It must be responded. It must be acknowledged. So after getting this command RRP P bit equal to 1, the B will send the acknowledgement which it wants to receive. Say RR, say RRI. It will send the RRI. Right. Similar thing happened for damaged acknowledgement also. Damage means RR is is transmitted. I mean RR B receives I and sends the RR sends RR I+1. Received I, so next acknowledgement will be I+1. But that is in error. Then that times what will happen after the reasonable times, say also since the cumulative acknowledgement here it is for sliding into flow controls, so A will transmit. There may be some other times the B will send the another acknowledgement. So from that the process will continue. So within reasonable times before the time expires, see the subsequent frames will be transmitted, right? Be transmitted. Even this RRI it is damaged. Next acknowledgement would be there to indicate indicate that the frames received successfully. This may be one case, but another case also there, just like damaged frames, damaged acknowledgement also. Say if the time expires, then it will transmit that common frames. the command message, that is RR with PB equal to 1. And that time B must be responded. If it does not respond, then you see again A will repeat. So this way, this process will continue for several times. Maximum number of times will be there. If it is not responded a certain number of attempts, then whole process will be reset. So these things are there. Now these things we are discussing through these examples. You see it here. In these examples, A is transmitting frames to B, F0, F1, F2, like these things, right? And F0, F1, F2. So after getting this F1, B acknowledges the frames RR2. That means it has received 1, ready to receive 2. By the time it has, it will arrive A already transmitted F2, F3, like this, F2, F3, F4. Right? Since because A will continue, because RR2, there may be another acknowledgement also, like these things after 2, 3. That's why A will continue unless it gets the negative acknowledgement or something like that. So it will continue. Now it will transmit this F3 and F4. Now this F4, the frame is damaged. It is not received by B, but it will continue. Here also you see B is again acknowledges after RR2, it acknowledges RR4, like these things. But by the time this RR4 will arrive here, subsequent frames will be transmitted. Even 5, 6 will be transmitted. Right, but after getting this, when B will receive 5, 6, last frame is received F3. So you see, you will see the frames are out of sequence. Out of sequence. So it will discard. It will discard these frames, and it will send the negative acknowledgement. You see, reject R. Which frame is not received? That will that will be mentioned here. Reject 4. So after receiving this negative acknowledgement, A will not only send this reject 4, this frame number 4, but also the subsequent frame that are already it has transmitted after transmitting 4. So 5, 6, etc. These things will be transmitted. So this is the case. This is the case 1. Next case, you see, after getting this F6. Now B transmits the acknowledgement RR7, but this RR7, say it is now lost. This acknowledgement, it is lost. Then what will happen? You see here, you can see it. Acknowledgement is lost, RR7, and that is lost. So, but A will continue to transmit, say 6 next frames. It is say F0, 0 to 6 frames, 7 frames transmitting. I'll tell you why it is 2 to the power 3. It is not the 8 frames. It will be at least 1 less. So next frame also will be transmitted. That is F0. F0 will be transmitted. Right. F0 will be transmitted, this F, but it is not still, since acknowledgement is not there after transmitting 4, 5, 6, even F0. So after certain times, you see somewhere here, say when the time expires. So after transmitting this F6, let us say F6. This A is equal to the timer, so this is the timeout. Timeout. It is supposed to receive this acknowledgement, but acknowledgement is not received, and the time also expires. Right. Then what will happen? A will send. I told you this command. One command, that is RR with PB equal to 1. RR with P, that is equal to 1. RR with PB equal to 1. Right. So when B receives this this frame, it will consider as a command frames, and it must be responded. So immediately it will respond after getting this one. It will respond. What it will respond? You see, the last frame it has received F0 successfully. So it will send. What it will send? Frame, can you suggest anybody? What would be the acknowledgement here after this? What will be the acknowledgement here? What the B will acknowledge? Can you suggest anybody quickly? What acknowledgement will be there? Anybody? Can you suggest what I should write here? What acknowledgement? Anyone can suggest it? So bolo. If you don't have any idea, so then also you said no idea. Or if you can suggest, you can tell. You can tell what acknowledgement it should be. कुछ तो बोलो, अभी एग्जाम दोगे, क्विज दोगे.
No idea, sir.
No idea. You see it, which the last frame it has been received F0. It has received F0. So whenever one frame is received, what will be the acknowledgement? Suppose if it is here, if you see it here, suppose acknowledgement here, F1 is received. The acknowledgement is RR2. That means it has received till frame number 1, ready to receive frame number 2. Now tell me what it should be. What it should be here? What it should be here? Tell me with this analogy. अब तो बोलो. No idea. बोल सकते कि ना बोलो?
Still not getting it, sir.
You are Pinky? What's your name?
Yes, sir. Yes, sir.
You see it here, F0, F1, 2 frames are transmitted, and B sends the acknowledgement. What is the acknowledgement here? Read it. What is the acknowledgement written here?
RR2.
Why it is 2? Why not 0, 1 or 3? Why it is 2? Not followed. Say yes or no. Anyone else? बाकी लोग सब लोग सो रहा है क्या ऑन करके? बोलो इसमें 2 क्यों लिखे हैं? इससे 2 क्यों लिखे हो बोलो? ये तो बोलो. ये समझ में नहीं आया तो ये भी समझ में नहीं आएगा. ये समझ में आएगा तो यू कैन राइट आंसर इट हियर. बोलो ये 2 क्यों लिखा है? पिंकी बोलो क्यों इसमें 2 लिखे हैं?
So I minus plus 1 की वजह से.
नहीं यहाँ पर देखो ना, I minus I plus 1 छोड़ दो तुम अभी. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 ऐसे करके देखो. 0, 1, 2, 3, 4, 5, 6 frames are transmitted like these things. 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5 like this thing. In this way frames are transmitted. I छोड़ो अभी. तो जनरल केस I told you. Now in the practical case example दे रहा है ना. 0, 1, 2, 3, 4 ये देखो 4 मिसिंग हो गया तो फिर 5, 6 इसको इसका कर दिया. फिर दोबारा फिर 4, 5, 6 भेजे हैं. ये तो गो बैक. इसका मीनिंग है गो बैक. It will go back and retransmit the frames which is lost as well as the succeeding frames. That's why the name is go back. Is go backs. It goes back and sends the frames, not that negligent element as well as the succeeding frames. अब बोलो इसमें 2 क्यों है सर? बोलो इसमें 2 क्यों है? इसका आंसर दे सकते हो कि नहीं? बोलो यस और नो. ये RR2 क्यों लिखे हैं?
No idea, sir.
ये क्या देख रहे हो? ये 0, 1 ये क्या ये देख पा रहे हो कि नहीं? F0, F1.
F0 so F1 ट्रांसमिट हुए.
हाँ F01 F0 फ्रेम 0 नंबर फ्रेम ट्रांसमिट हुआ, 1 फ्रेम ट्रांसमिट हुआ. व्हाट इज द मीनिंग ऑफ RR? Ready to receive. Ready to receive means if I write say RR5, that means it has received 4 and ready to receive 5. आप समझ में आया? इसको बोलो. आप बोलो RR2 मतलब अब क्या मतलब हो गया इसका? RR2.
It is ready to receive the second signal.
Second frames, not
Second
second,
frame.
actually third frame. Not do say like these things. It is frame numbers, 1 frame, 2 frames, 3 frames, like these things. I have told you, this sliding the flow controls. 1, 2, 3, 4. The different frames are transmitted. Frames. And 1 frame, second frame, third frames, like this. 2 actually third frames. 1, 2, 3. तो इसमें RR2 मतलब क्या है? Before this number till 1 till 1 all the frames have been received by B and ready to receive frame number 2, because 1 has been received, next number is this one is there. That is the meaning of it. Now you tell me what will be the value, what should be the value here? आपको समझ में आया तो क्या होना चाहिए? यहाँ तो फ्रेम तो कोई लॉस्ट नहीं हुआ, फ्रेम तो रिसीव हुआ है, सिर्फ एक्नॉलेजमेंट लॉस्ट हुआ है. सो अभी बोलो इसमें क्या एक्नॉलेजमेंट होना चाहिए इस जगह में, जो बी ए को भेजेंगे? बोलो क्या होना चाहिए? भी समझ में नहीं आ रहा है. कौन सा लास्ट फ्रेम रिसीव किया है यहाँ पर? पिक्चर F0 रिसीव किया है, तो व्हाट शुड बी द एक्नॉलेजमेंट हियर? RR1. इतना डिफिकल्टी है? उतना टाइम मिलेगा तुमको 0.5 में आंसर?
उसके ऊपर कंफ्यूजन क्या? RR समथिंग P1.
हाँ, ये तो अलग केस है, ये एक स्पेशल केस है. वो जो भी केस है, एक केस क्यों है वो तो समझने की कोशिश नहीं कर रहे हो ना, बार बार बोल रहे चिल्ला रहे हैं. एक टाइम आउट हो जा रहा है. देखो एक केस है जो टाइम के अंदर ही भेज रहा है, जो टाइम के अंदर ही रिजेक्ट नेगेटिव फ्रेम भेज दिया. तो नेगेटिव फ्रेम जैसे भेज दिया, then it will send not only that frame that is lost but also the succeeding frames. देखो 4, 5, 6 समझ में आ रहा है? तो फ्रेम 4 लॉस्ट हो गया, तो डी क्या किया, बाकी फ्रेम रिसीव किया, लेकिन वो उसको कंसिडर नहीं करेगा जब तक ना फ्रेम 4 उसका पास आएगा. तो यू सी दैट्स व्हाई इट सेंड्स द एक्नॉलेजमेंट रिजेक्ट 4. रिजेक्ट 4 मतलब till frame number 3 is received but frame number 4 is not received. No, not like that. I mean, simply it will say which frame is not received, reject. RNR का मतलब ठीक है, उस समय कंटिन्यू चलेगा. लेकिन रिजेक्ट 4 मतलब फोर्थ फ्रेम नॉट रिसीव्ड. So fourth frame क्या, then A will send not only this fourth frame but also the succeeding frames. कौन frames? ना 5, 6 ऑलरेडी ट्रांसमिट किया, इसको दोबारा ट्रांसमिट करना करेगा. It has to transmit again 5 and 6. That's why the name is go back in ARQ. तो ये टाइम आउट जब हो जाएगा, ये इसमें टाइम आउट हुआ नहीं, उसके अंदर ही मिल गया था. इसमें क्या हुआ, और इसके अंदर वो नेगेटिव एलिमेंट भेजा नहीं है, ये तो ठीक भेजा था. ये जैसे 6 सक्सेसफुली रिसीव किया, तो नेक्स्ट इट सेंड्स द एक्नॉलेजमेंट RR7, बट दिस एक्नॉलेजमेंट इज लॉस्ट. But they do not know whether it is lost or it has been received or something like that. It seems that frame it is not sending. Maybe it will send the cumulative acknowledgement. Maybe next time, next acknowledgement it will send it, right? जैसे देखो इसमें हर acknowledgement नहीं भेज रहा है. RR1, RR2, RR3 ऐसा तो नहीं भेज रहा है. RR2 भेज रहा है, next RR4, maybe next RR5, like these things. In this way, cumulative acknowledgement. ये तो slide window flow control है ना. तो ये केस अलग केस है. इसमें जब टाइम एक्सपायर कर गया, उसके बाद टाइम खत्म हो गया, तो उसके बाद क्या करेगा, जब तक कुछ भी नहीं आ रहा है, लेकिन ये तब तक वो ट्रांसमिट कर दिया F0 फ्रेम्स. वो क्या किया, तब एक कमांड फ्रेम भेजा है. ये फ्रेम नहीं है, एक कमांड RRP = 1 P बीट. एक्चुअल प्रोटोकॉल हम लोग जब पढ़ेंगे तो नेक्स्ट उसके बाद HDLC पढ़ेंगे तो और क्लियर होगा. हाई लेवल डाटा लिंक कंट्रोल प्रोटोकॉल्स, ये हम लोग तो मैकेनिज्म पढ़ रहा है, एक्चुअल प्रोटोकॉल इसमें यूज होता है इस तरफ का. तो वो क्या करेगा, एक कमांड फ्रेम भेजेगा RRP, इसको रिस्पॉन्ड करना ही है. जैसे B मिलेगा, इसको B को रिस्पॉन्ड करना है. अब तक तो B चुपचाप था, इसके बाद करने के बाद, लेकिन जब इस फ्रेम मिल जाएगा उनको, तो इट हैज टू रिस्पॉन्ड. तो वो क्या किया, जो वो देख रहा है, जो F0 तक तो मिला है, ये कमांड इसको आंसर देना है. दैट मीन्स it will send the acknowledgement RR1. F0 तो मिला है उसको लास्ट फ्रेम्स. और ये तो कमांड फ्रेम है, ये तो ये नहीं है, ये तो एक्चुअल फ्रेम नहीं है, कमांड फ्रेम है. कमांड एक कमांड है, ये डाटा फ्रेम नहीं है. तो जैसे ये मिलेगा, देन ये विल सब्सिक्वेंटली ये ट्रांसमिट. जैसे मिलता है, कौन सा फ्रेम ट्रांसमिट करेगा बताओ, अब समझ में आया? तो अभी बताओ कौन सा फ्रेम ट्रांसमिट करेंगे? ए जब RR1 मिलेगा तो ए कौन सा फ्रेम ट्रांसमिट करेंगे? अब तो बताओ।
F2.
F2 कहाँ से? F1 कहाँ गया? खो गया? तुम ले लिया क्या? F1 कहाँ गया? F2 कहाँ से बोल दिया तुमने? F0 तो यहाँ ट्रांसमिट किया और RR1 है। 1 मतलब RR1 से वो एक्सपेक्ट कर रहा है। अगर F2 कर देगा, मान लो F2 ट्रांसमिट कर रहा है, गलत नहीं हो जाएगा? F1 फ्रेम कहाँ गया? कैसे तुम बोल दिया F1 है, F2 है? आप अपना अपना गलती अपना पकड़ो। अब अगर हम F2 लिखेंगे, गलत होगा कि सही होगा? बोलो बोलो, बोलते जाओ।
गलत होगा सर।
गलत होगा ना? आप समझ में है ना? ये गलत है, तो यही चीज समझना है। समझ रहे हैं ना? ये क्या होना चाहिए? क्या होना चाहिए बोलो? F2 के बदल में क्या होना चाहिए? सही चीज बोलो।
F1, F1.
F1 ही होना चाहिए। इतना ये क्यों है? तो इतना F1 होना चाहिए। F0 है, F1 होगा, नेक्स्ट F2 होगा। इन दिस वे इट विल कंटिन्यू। फिर ऐसे होगा तो ऐसे ट्रांसमिट करते जाएगा, तो बी अगर फिर ऐसे केस होगा तो ऐसे ऐसे करेंगे। अब समझ में आया कि नहीं है? बताओ इसमें कौन सा गलत लग रहा है, कौन सा डिफिकल्ट लग रहा है? बोलो बोलो, तो कौन सा डिफिकल्ट लग रहा है? बोलो कौन सा चीज डिफिकल्ट लग रहा है? बोलो।
सर डिफिकल्ट नहीं है सर,
हाँ?
एक और बार रिपीट कर दीजिए।
एक मिनट रुको। ओभिक सेन, ओभिक प्रेजेंट है? अब सबको ऑप्शन कराएंगे आज। ओभिक प्रेजेंट है कि नहीं है?
उसको रिपीट कर दीजिए।
वो रिपीट करेंगे, उसके पहले हम देखते हैं व्हाट एक्शन ए हैज टेकन एंड व्हाई इट हैज टेकन RR7. What is the meaning of RR7? What is the full form of RR7? Answer immediately. If you take time, that means you are consulting to others or consulting to books. I understand. You tell me what is the meaning of RR7? There no answer.
Sir, 7, sir,
You
ready
do not know what is the meaning of RR. You tell me what is the meaning of
sir,
RR.
ready to receive.
What is the meaning of RNR?
Sir, RNRI.
That also I told you. What is the meaning of?
RNRI. I do not know RNR, sir.
So why you tell me what is RRP?
Sir,
What is RRP? That means you people are simply attending this one but not listening at all. Let the teachers, you are having problems till now. Where you are having problems? Pinky, tell me.
So the discarded section.
Which one? Discarded
Sorry, the distorted one.
I told you that this whenever is discarded means here, whenever the frames are out of sequence, you see 0, 1, 2, 3, these frames are received, and next it has received. After this, the no frame is received. You see it here. Supposed to receive 4, but it is not received. What it has received? It has received 5, 6. So after 3, if it receives 4, 5 and 6, it is out of sequence or not? It is out of sequence.
Yes, sir.
After 3, it should be 4, na? So, lekin after 3, it is 5, 6. That means it is out of sequence. If it is out of sequence, then the frames will be discarded. Unless the actual frame is received, it will not accept any other frames. That's why immediately it will send the negative acknowledgement, reject 4. As soon as A gets this reject 4, then it will send not only this frame 4, but also the succeeding frames. आप समझ में आया? आप समझ में नहीं आया तो 3-4.
Yes, sir.
Anyway, so these things are there. Now quickly see the selective. Another protocol is here, that is selective reject. There you see here it goes back, right? It goes back and sends the discarded frames, I mean damaged frames as well as succeeding frames. But another protocol is there which is called selective reject, ARQO. you people are having communications, but I don't know how. Do you think you are accessing email? It's so easy. So many protocols are there. These type of protocols are there. You are writing email, you are getting it immediately. But in between, so many processes, so many networks, so many things are there. You do not try to know. At least you should try to know, because you are a communication student. So here you see A, B, say this is F0, F1, F2, F2, F3, like these things. So it is F0, F1, F2, F3. The frames are transmitted as usual. This is sliding window flow controls. So there can be cumulative elements after say 0, 1. You see, it sends the acknowledgement. This should be after sending. Now you tell me, Pink, you tell me what it should be right here. What it should be acknowledgement.
RR2.
Exactly, RR2. It has received 0, 1, next to RR2. It has RR2. By the time it will reach here, it will send F3 also. F3, F4, etc. F3. At least one frame will be 1 to 2 frames. It will transmit. Right. So F3, F4, as before said, same problem. If you just consider it here, so it is F4. It transmitted F4, but that is lost. Right, lost. But A will continue to transmit. The slide into flow controls, F5, F6, at least 2 frames it will transmit. Even if it does not get the acknowledgement, F5, F6, right? Say after getting this F3, it has sent also the acknowledgement RR4 as before. You see, I'm just repeating this one, but slightly different protocol. You see it. What is the difference? You can understand. So here will be, as usual, it will be RR4 because F3 received RR4, right? And the things. Now, whenever you see it earlier, as soon as F5 is received, B discards all the frames. But here, you see, B will not discard in this protocol. Here, they will be buffered. These things will be buffered. Buffered, right? And you see, but of course, B will send the selective reject. After getting this 5, it will send the one acknowledgement will send is SREJ, selective reject 4. That means selectively, not the cumulatively. Here you see, it will ask the damaged frames to send the damaged frames only, not the succeeding frames 5, 6. So selective reject 4. So after getting this acknowledgement, then A will resend this F4. Because F4 is lost, so it will send F4, right? And next, it will not send 5, 6 because already it is in this protocol. This frame will not be repeated. So next frame is supposed to transmit. Say F6, F7 is here, then it will send F7. If it is here, F7 will be there. Next, again, it will be F0 will be there. If 0 to 7, if you just consider here window size, then these ones and like these things. Right. Since F6 is here, so it will send after getting this F4. It might send the this acknowledgement RR7. That means 6, 5, 6. It has received, ready to receive the frame number 7. Right. By the times already it has been transmitted F7s. So again, you transmit 0, 1, 2, 0, 1, 2, like these things. And say after getting this 0, A sends the B sends the acknowledgement. That is RR1. As before, see RR, it has sent, here it is RR7, let us say it is RR1. Received F0, say RR1, and that is say lost. This acknowledgement is lost. One frame is lost, acknowledgement is lost. And say after 7, 0, say somewhere here, you see, after getting this acknowledgement, right? Here it will equipped with the it will be equipped with the timer, right? And when the time expires, as before, if the time expires a certain time within the time interval, it's okay. If the within time interval, if selective reject this type of acknowledgement is there, it's okay, fine. But if the time expires, then what will happen? After transmitting say F2, A will repeat the same things, the command frames. It will issue the command frames, which command frame, which is, you see, RR with P bit equal to 1. P bit equal to 1. And as soon as this command frame is received by B, it must be responded. That means it must respond with the acknowledgement. What acknowledgement it should send? Say F2, it has been received. So definitely it will send. Pinky, you tell me what acknowledgement it will send?
RR3.
RR3, exactly, RR3, right? RR3, so it will send the RR3, RR4, RR3, RR4, sorry, F3, frame 3, frame 3, this is frame 4, like this is. Same, similar to this one, only difference is this, you see it here, it is not transmitting the, it is not repeating the frames that already transmitted, right? That is the difference between go back NAR cube and selective reject AR cube. So what do you feel? Which one would be better? Go back NAR cube or selective reject AR cube? Anyone can suggest it? Which one would be better for say internet, if you like these things? Which one would be better? Guess कर सकते हो कि कौन अच्छा होगा?
Second one.
नहीं, ये अच्छा होगा। यही सबसे वाइडली यूज होता है ए, क्योंकि देखो इसमें अच्छा लग रहा है जैसे एक ही फ्रेम भेजना पड़ रहा है इसको, एक ही फ्रेम, लेकिन एक चीज देखो, इसको कॉम्प्लेक्स सॉफ्टवेयर चाहिए। एक तो नंबर, व्हाट आर द डिसएडवांटेजेस, यू केयरफुली नोट इट। वन थिंग इज बफर स्पेस शुड बी क्वाइट लार्ज, सफिशिएंट बफर स्पेस होना चाहिए to store these the frames, एक नंबर 1। नंबर 2, एक कॉम्प्लेक्स सॉफ्टवेयर होना चाहिए बी के पास, जब क्योंकि आफ्टर 5 6 अगेन फ्रेम 4 इज रिसीव्ड, सो फ्रेम 4 को फिर सीक्वेंस में इसको बैठाना है। सो सॉफ्टवेयर, सुटेबल सॉफ्टवेयर, कॉम्प्लेक्स सॉफ्टवेयर विल बी रिक्वायर्ड टू प्लेस द फ्रेम्स इन सीक्वेंस। नंबर 2 हो गया। नंबर 3 में देखिए, एक को भी सेम प्रॉब्लम होगा, इसके पास भी कुछ सोफिस्टिकेटेड सॉफ्टवेयर होना चाहिए, सो दैट you see it will send 1 2 3 in this way, but here you see after getting the selective reject 4, it has already transmitted 5 6, next frame it should submit 7, no, it has to transmit F4, that means some out of sequence frame को इसको transmit करना है, तो सॉफ्टवेयर में complexity बढ़ जाएगा। तो that's why, am I clear? जो अच्छा बोल रहे थे समझ में आया? इसका ड्रॉबैक ज्यादा है इसका, इसके कंपैरिजन में। इज इट क्लियर और नॉट? जल्दी बोलो।
यस सर।
हाँ, तो इसलिए सेकंड जो मेथड जो है ना, एक्चुअली थर्ड मेथड है, थर्ड मेथड ज्यादा पॉपुलर नहीं है, लेकिन इसमें एक चीज है जो सिंगल फ्रेम है, ये एक पर्टिकुलर केस में यूजफुल है। वो सैटेलाइट लिंक में, जब सैटेलाइट कॉम्युनिकेशन पढ़ोगे, जो सैटेलाइट लिंक में प्रोटोकॉल पढ़ोगे, देखना इसमें सेलेक्टिव रिजेक्ट उसमें थोड़ा ज़्यादा यूज होता है, क्योंकि इसका उस समय सेटलमेंट में लॉन्ग प्रोपेगेशन डिले है, प्रोसेस के कारण से उसमें इफ यू ट्रांसमिट अदर फ्रेंड्स आल्सो देन प्रॉब्लम विल बी देयर. So in that case it is useful. Otherwise, widely used popular method is this go back and ARQ, right? ये चीज हमेशा ख्याल रखना. अच्छा, और एक चीजें हम बार बार बोल रहे हैं, जो देखो बार बार बोल रहे थे, जो मान लो 3 बिट सीक्वेंस नंबर है, तो स्लाइडिंग फ्लो कंट्रोल हम लोग क्या देखे थे, अगर 3 बिट है, 3 बिट, तो सीक्वेंस नंबर क्या 0 to 7 होना है, 2 to the power 3 8 फ्रेम्स होना चाहिए, लेकिन एक फ्रेम कम होना चाहिए, एक्चुअली 2 to the power k-1 होना चाहिए एक फ्रेम. विंडो साइज जो ए का विंडो और बी का जो विंडो है, वहाँ लोग जो देखे थे उस समय स्लाइडिंग फ्लो कंट्रोल में, देखो विंडो साइज पहले तो फिक्स करना पड़ता है ना, सेट करना पड़ता है, तो 4 फ्रेम्स हो सकता है, 4 हो सकता है, 5 हो सकता है, 6 हो सकता है, 7 7 8 8 हो सकता है, लेकिन एक फ्रेम कम होना चाहिए 2 to the power k-1. इसका कारण क्यों, देखिए बहुत इंपॉर्टेंट है, इसका कारण देखो, समझो ठीक से. मान लो सर्टेन इंस्टेंट स्टेशन ए सेंड्स फ्रेम 0, फ्रेम F0 सेंड किया नहीं, एंड इट गेट्स द एक्नॉलेजमेंट RR. ऑब्वियसली 0 सेंड किया तो एक अगर मिलेगा तो मान लो RR 1 होगा, क्योंकि 0 रिसीव किया है. नेक्स्ट रेडी टू रिसीव फ्रेम नंबर 1 onwards, राइट 1. So after getting these things, then A sends the frames 1 2 3, क्योंकि 2 to the power 3 बिट है, तो 2 by 8 फ्रेम्स है, तो 2 by 1 2 3 करके कब तक चलेगा, बोलो कब तक चलेगा, कब तक ये ट्रांसमिट करेगा, अगर क्यूमुलेटिव है तो ट्रांसमिट करते रहेगा, कब तक बोलो, बोल सकते हो कितना नंबर फ्रेम तक ये ट्रांसमिट करेगा मैक्सिमम, कोई बोलो. 2 to the power 3 है, तो कितना फ्रेम्स मैक्सिमम ट्रांसमिट कर सकते हैं, बोलो
7 सर.
7 तक, और 1 2 3 7 तक कितना हुआ, गिनो कितना फ्रेम हो गया 7 तक, 1 2 3 4 5 6 7, 2 to the power 3 मैक्सिमम फ्रेम कितना होना चाहिए, मैक्सिमम फ्रेम कितना होना चाहिए, इक्वल टू 2 to the power 3 इक्वल कितना, बोलो 8 है ना, तो कितना फ्रेम होना चाहिए, नेक्स्ट 0 ऑल्सो इट में ट्रांसमिट. इस समझ में आया कि नहीं. अगर विंडो साइज 8 है, तो आफ्टर रिसीविंग दिस एक्नॉलेजमेंट RR1, इट कैन ट्रांसमिट 1 2 3 4 5 6 7 0 8 फ्रेम्स, अगर विंडो साइज 8 है तो. समझ में आया कि नहीं. तो आफ्टर गेट समझ में आया, ये सर नो बोलो, ये सर नो बोलो, ये 0 इसमें इंक्लूड होगा कि नहीं, है कि ना, बोलो ना.
Yes sir, yes sir.
तो विंडो साइज 8 है ना, तो मैं 8 फ्रेम्स मैक्सिमम ट्रांसमिट कर सकते हैं, तो 0 होगा. सो आफ्टर गेटिंग दिस 0, व्हाट द बी विल सेंड, सपोज इतना 0 मिला, तो व्हाट बी विल सेंड द एक्नॉलेजमेंट, बोलो पिंकी, बोलो क्या होना चाहिए, क्या एक्नॉलेजमेंट भेजेगा 0 के रिसीव करने के बाद,
1.
दैट मींस RR1. पहले क्या भेजा था RR1, अभी भी भेज रहा है, क्या बोल रहा है RR1. तो दोनों RR जब जैसे भेजेगा, क्योंकि ये देखो RR1 भेजे क्योंकि क्यूमुलेटिव है, कभी ये RR4 भी भेज सकता था, कभी RR7 RR1 भी भेज सकते हैं सम केस में. इन सम केसेस B कैन सेंड RR1 ऑल्सो, अर्लियर इट हैज सेंड RR1, अभी भी RR1 भेज रहा है. तो ये इसमें क्या मीनिंग हो सकता है, ये मीनिंग हो सकता है कि ऑल द फ्रेम्स दैट A हैज ट्रांसमिटेड आर सक्सेसफुली रिसीव्ड, है ना. लेकिन ये भी मीन हो सकता है जो ऑल द 8 फ्रेम्स दे आर लॉस्ट, all the 8 frames are lost and B is sending the acknowledgement, again is sending the acknowledgement RR1. ये हो सकता है कि नहीं, बोलो समझ में आया कि नहीं, बोलो. हम जो बोल रहे हैं इसको समझ में आया कि नहीं आया, बोलो. 2 चीज हो सकता है, एक तो हो सकता है जो अगर B फिर से RR1 भेजेगा, तो एक व्हाट ए कैन अंडरस्टैंड दैट all the frames they transmitted successfully received and it is the acknowledgement. or it can also assume, it may the A can understand, it can assume that all the 8 frames have been lost, and it is asking the frame numbers. Again, it is frame number 1. तो ये समझ में आया कि नहीं है कि ना, बोलो ना।
Yes, sir.
समझ में आया ना? तो एक कंफ्यूजन हो गया है ना, 2 कंफ्यूजन हो गया। मान लो ये सब सक्सेसफुल रिसीव्ड हो गया, फिर भी ये सोच रहा है जो समझ, yes, he understands that all the frames lost, then again we retransmit all those things. So that is the problem. So to avoid these problems, the frame window size should be at least 1 less. Then this problem will be avoided. That's why maximum window size can be 7 for 3-bit. If you use the 3-bit sequence, then maximum window size should be 7, 2 to the power k minus 1. समझ में आया कि नहीं? समझ में आया? तो ये चीज नहीं होगा, तुम करके अपना करके देखना, ये नहीं होगा। तो ये जो कंफ्यूजन है, दैट कंफ्यूजन विल बी एब्सेंट। और एक चीज देखो इसमें, जल्दी देखो, और एक चीज है, सिलेक्टिव रिजेक्ट में जो विंडो साइज है और क्रिटिकल है। मान लो ये थोड़ा सा क्रिटिकल देखो, मान लो ए फ्रेम्स ट्रांसमिट किया फ्रेम 0, राइट, टू F6, F0 to F6, frame it has transmitted A, and B receives all the 0 to 6, all 7 frames. B receives all 7 frames and sends the acknowledgement RR7. 6 तक रिसीव किया है, तो it sends the acknowledgement RR7. Next you see it sends acknowledgement, but this acknowledgement is lost, right? And also the A times out. Then what will happen? You see times out. Then A will retransmit this frames 0. Frame 0 will be retransmitted, right? Then you see B already it has received the frame 6. So what happens? As soon as B, you can understand, you can see, you can remember all those things. Remember sliding window flow controls, window size. After receiving 6, it will set window starting with 7, next 0, like these things up to 5. In this way, right? If 6, if it is considered, if you consider 6, then you see 0 to 6, 7. Okay, 7. We are considering 7. I mean, considering that one window less, right? So you see it here. It has set its window. It has set its window 7 to 5. So what happens? You see the then. If A sends the frames after repeats the frames F0, if the sends F0, that means what it will understand that the F7, frame number 7, it has lost. Frame 7 has been lost, and it's a new frame 0 which it accepts, right? If A repeats these frames F0, right? I mean, if RR7, if it is not received and times out is here, then A will start transmitting F0 onwards. So what it happens, B will understand that the 7 has been frame 7 has been lost, and it's in new frames. So this problem would be there. This problem can be avoided in this case for selective reject. Here it is actually. The frame size should not be more than half the range of the sequence number. That means this times the window size maximum can be 2 to the power k minus 1. In the sliding window flow controls, it is 2 to the power k minus 1. But in this case, it should not be more than half the range of the sequence number. So that is about 2k minus 1, right? For k bit, for 3 bit, you can calculate. For 3 bit, 4 bit, etc. Whatever may be the case, you can calculate. For sliding window, or if it is go back NAR cube or sliding window flow controls, that times it is go back NAR cube with sliding window flow controls, then it maximum window size will be 2 to the power k minus 1, and in this case, it is 2 to the power power will be k minus 1. It should not be more than the half the range of the sequence number. So these things are there. You try to go through it, then it will be more clear. If you think about it, what I have mentioned, the 2 points for this sliding flow control and selective reject ARQ. I mean, go back and ARQ and selective reject ARQs. And just 1 minute. Here you see utilization efficiency. We have seen it with errors. You see, since if error is there, you have seen it for retransmission is here. So in this case, you see stop and wait ARQ. We have seen it utilization efficiency order. We have seen 1 by 1 plus twice A, 1 plus twice A. But this times you see, I mean, it is actually by definition, it is a frame transmission time divided by total times, TT. Total times by the frame transmission times. That is the utilization efficiency. Right. But in this case, when error is there, some retransmission will be there. So that times you will be actually TF transmission time divided by some factor will be there, the NR times TT. Number of retransmissions, expected number of transmissions of a frames. So in this case, stop and wait ARQ, actually this will be 1 by NR into 1 plus twice A. So that is the utilization efficiency for stop and wait ARQ. We'll see what is the value of NR next time. We'll see it. If you consider some probability, it will say. Anyway, today this much. Next time we'll see. कोई किसी क्वेश्चन है तो पूछो, लेकिन जो हम कुछ नाम नोट किए हैं अभी तो डिफेंड कर